Now we move from PAM concepts into a real enterprise platform, CyberArk. It works as a control plane for privileged access, helping organizations store secrets, manage accounts, broker sessions, record activity, and reduce risk across servers, clouds, databases, and applications. Up to this point, we have built the foundation: privileged identity concepts, core PAM controls, and hands-on Microsoft Entra PIM operations. From here, we apply that knowledge to enterprise PAM platforms, starting with CyberArk, then comparing other major vendor approaches. CyberArk matters because privileged access is where enterprise risk concentrates. Domain admins, root users, service accounts, database admins, and cloud administrators can all unlock critical systems. CyberArk provides a centralized control layer between those identities and the resources they reach. Instead of exposing passwords directly, it vaults credentials, rotates them, brokers sessions, records activity, enforces policy, and produces audit evidence. The result is lower credential theft risk, slower lateral movement, and stronger accountability. In hybrid environments across data centers, cloud, and remote locations, that consistency turns privileged access from an ad hoc exception into a governed security process. CyberArk's architecture centers on the digital vault, the protected system of record for privileged credentials, SSH keys, and secrets. Users and administrators work through PVWA to request access, approve workflows, and manage accounts. CPM enforces credential hygiene by verifying passwords, reconciling drift, and rotating credentials based on policy. PSM brokers privilege sessions so credentials are not exposed, while activity is recorded and controlled. PTA adds behavior analytics and risk detection. Around these services, APIs, SDKs, directories, SIM, ticketing, cloud, databases, and target systems connect CyberArk into the wider enterprise workflow. The digital vault is the security core of privileged access management. It holds the highest value items: privileged passwords, SSH keys, application secrets, and the metadata needed to manage them. But storage alone is not the goal. The vault is hardened, isolated, encrypted, and tightly audited. Every action is controlled: who may retrieve a credential, who may manage it, who can rotate it, who must approve access, and who can audit activity. That makes the vault the trusted source of truth for managed privileged credentials. PVWA is the main front door into CyberArk. A privileged user can search for an account, request access, provide a reason, and launch an approved session such as RDP, SSH, or web. Approvers use the same portal to review requests and enforce policy decisions. Administrators use it to onboard accounts, manage safes, assign platforms, and reach reports. Behind the scenes, PVWA connects to enterprise identity systems like Active Directory, LDAP, SAML, and MFA, so access is tied to corporate identity and controlled through a consistent workflow. The central policy manager is the automation engine behind credential hygiene. It starts with policy. When should this password change, and what rules must it meet? CPM verifies the vaulted password against the target system. If rotation is due or triggered by checkout, use, or suspected compromise, it changes the password and writes the new value back to the vault. If the account is out of sync or the password is unknown, CPM reconciles it using approved controls. Every result is audited across Windows, Linux, databases, network devices, and applications. Privileged session management changes how admins connect to critical systems. Instead of giving a user the privileged password, CyberArk brokers the session. The user requests access through PVWA. PSM opens the approved RDP, SSH, database, web, or application connection, and the credential is injected behind the scenes. The user can work, but never sees or copies the password. Because the traffic passes through PSM, the organization can record sessions, audit commands, log keystrokes, and terminate risky activity. This separation reduces exposure while still allowing productive privileged access. CyberArk is part of a larger security ecosystem, not just a standalone vault. Privileged Threat Analytics watches privileged activity for risky patterns, such as unusual access times, new locations, escalation, or repeated failures. Connectors let the platform reach the systems where privileged accounts actually live, including servers, databases, network devices, cloud services, and applications. Enterprise integrations connect PAM to monitoring, ticketing, identity, and MFA tools. APIs and automation help teams operate at scale by onboarding accounts, retrieving secrets safely, and embedding privileged access controls into everyday workflows. CyberArk's safe model is easiest to understand as containment plus control. The vault is the secure backend, while safes organize access. A safe groups related privileged accounts, such as Windows administrators, Linux root accounts, database DBAs, or network devices. Each account carries metadata including username, address, platform, policy, owner, and credential state, so CyberArk knows how to manage it. Permissions are assigned at the safe level, controlling who can view, retrieve, use, manage, approve, or audit credentials. This creates clean separation of duties across privileged access workflows. CyberArk control works through 3 layers. Platforms handle the technical rules for each account type: how passwords are built, when they rotate, how connections launch, and how verification happens. Policies add workflow decisions such as approvals, ticket checks, MFA, time limits, and password rotation after use. Permissions define what a user can actually do inside a safe, from listing and retrieving credentials to approving requests or reviewing audit records. Good design keeps these layers aligned, so access is least privilege, granted just in time, enforced consistently, and easy to prove during an audit. Account onboarding turns discovered privileged accounts into governed assets. Discovery finds accounts across servers, databases, directories, network devices, applications, and cloud environments. Each account is then classified and mapped to the right safe, platform, policy, and owner. Once assigned, CyberArk can verify the credential, rotate the password, configure reconciliation, and enable controlled access workflows. The final step is maturity: consistent naming, clean metadata, accountable owners, and periodic reviews. Done well, onboarding is not a one-time import. It creates an ongoing cycle where accounts stay vaulted, rotated, monitored, and governed. A strong CyberArk workflow gives users a clear path to privileged access while keeping control with the platform. The user authenticates, searches PVWA for the account or target system, and submits a request. Depending on policy, CyberArk may require a business justification, ticket number, approval, MFA, or a limited access window. Once approved, the user either retrieves the password, if allowed, or launches a PSM session without seeing it. Afterwards, CyberArk records the activity, preserves audit evidence, and can rotate the credential so the next session starts clean. When privileged access is brokered through PSM, the session becomes evidence, not just connectivity. Imagine a DBA connecting to production after hours. CyberArk can preserve who requested access, who approved it, the ticket number, start and end time, commands executed, and whether the password was rotated afterward. Security teams can replay the session, search command history, inspect keystrokes or metadata, and correlate failed attempts or policy violations. That visibility turns suspicious activity into an investigation trail, supporting compliance reviews, incident response, forensics, and clear accountability for privileged users. You now have the CyberArk Foundation, the digital vault at the center, with PVWA, CPM, PSM, PTA, connectors, safes, platforms, and policies working together. The key ideas are structured access, separation of duties, credential protection, monitored sessions, and audit evidence. Next, we turn this architecture into implementation concepts, then compare CyberArk with other PAM vendors.